Okay, so let's start filming this. So when you think of an acid, when I think of an acid, I've been doing this my entire adult life. It's a little scary. I've been doing this stuff for 40 years. Can you imagine? And between studying at college and the university, as the Europeans would say, and teaching and working in industry, when I think of an acid, this is what I think of. I think of this. When I think of a base, I think of that. Okay? So that was given to us by Arrhenius, Swedish chemist. You said he's Dutch?
No, he's Swedish.
He is Swedish. Okay, so we had okay, I understood. I have a Dane in class who is an expert. He's my Scandinavian expert. So anytime we have a Swedish or Norwegian, whatever, okay, excellent. So Magnus did that research for me. All right, now, so we use these different theories from Arrhenius to Bronsted-Lowry to Lewis to explain acids and bases in different situations. So the application of these theories, the application is very situation specific. Yeah? But by and large, as a young chemistry student, you have to study the three theories. At the definition level, at least. Okay? At the thinking level, you're really not going much beyond Arrhenius. Yes? If you want to start to become if you're a young chemistry student who wants to take chemistry seriously, then you're going to want to, at this level, maybe look at Lewis a little bit more closely, etc. Clear? But by and large, this is the way we define an acid and a base. We use the Arrhenius approach. Now, I want to look at what happens, specifically what happens at the at the micro level. You know, what's happening when I put the salt of a weak acid, when I put the salt of a weak acid in water? What is actually happening? What are the dynamics involved? When I put the salt of a weak acid, so let's take a pretty standard weak acid, okay? Let's take a pretty standard weak acid. And I'm going to say that that weak acid is acetic acid, okay? I think they call it ethanoic acid in the book. It's like a pretty common thing. When I was a young student, we always called it HAC. HC2H3O2. Okay, and I have it on my lecture that I'm making. I have some pretty nice ball and stick models of them. So it's going to look like this. Okay, that's acetic acid or ethanoic acid. Where does ethanoic acid come from? Well, it's a kind of an organic chemistry nomenclature. A 2-carbon, see, carbon has 4 bonds here. 1, 2, 3, 4. This is called a hydrocarbon. This is called ethane. Ethane for 2 carbons. 1 carbon would be methane, right? A 1-carbon alcohol would be methanol. A 2-carbon alcohol would be ethanol. A 3-carbon propane, a 3-carbon alcohol would be propanol, etc. Understood? Butanol, right? So those are the prefixes. So it's mono for 1, ethane for 2, meth for 1, eth for 2, Propane, what's 4? Anybody know? Butane, pentane, hexane, heptane, octane, you've heard of octane in a car? Yeah. Actually, gasoline is a solution with a lot of different things. It has some heptane, hexane, nonane, some decane, but it's predominantly, it's rated based on its octane. Yes? Now, so that's where you get some of the nomenclature. So when you say ethanoic acid, you call this ethanoic acid. Some of you are taking IB chemistry. Who's taking IB chemistry in here? So it's mostly in the other class, okay? Who's taking AP chemistry in here, maybe? Okay, all right. So what happens is, this is something you're gonna do next year. This is important. So ethanoic, OIC, that comes from this. That's called a carboxyl group. That's called a carboxyl group. Yes? Get it? Carboxyl group. So the carboxyl group, the ending you put on the, what's the ending called of a word? How do you say that in English? I'll give you a hint. The beginning of it is called, if you put it on the beginning, it's called a prefix. What is the ending called? Suffix. Okay? So this suffix indicates the carboxyl group. So some people call it ethanoic acid. That's more scientific. But if you're going to call it by its common name, it's acetic acid, acetic acid. Okay? Vinegar. Vinegar. That's the active ingredient in vinegar, right? When I was a kid, if my mother, kids don't generally have very spicy meals. Anybody have any younger brothers and sisters? Okay? Do they like spicy meals? Yes. They like, Elizabeth, you're always contrary. Okay? You are so divergent, it's coming out of your ears, which is a good thing. However, most children don't like spicy foods. They like the basic stuff, hamburgers, hot dogs, pizza. They don't like Thai food with extra hot sauce on it. They go out of their minds. They don't like it. Their palates, their mouths are very sensitive, and their stomachs. They don't like that stuff. How many people have younger brothers and sisters who don't like that stuff? Yeah, they just don't do it. And they will do that as they get older. However, I was a little weird. I was kind of like what Liz defines, and I used to experiment with food as a young person, and I used to get a little bit of a sour stomach, acid indigestion, and it was the first time I got it, I thought, a dragon crawled down my throat that night. That's what my father said. You slept with your mouth open, and the dragon crawled down your throat, and he's breathing fire into your stomach, and I ran out to my mother screaming, thinking I had a dragon in my stomach. And what my mother gave me was a spoonful of vinegar. She gave me a spoonful of this. What that is a weak acid. And what it does is it helps to bring down the acid level in your stomach. The pH in your stomach. It reduces it. Your pH in your stomach is, it's like a 1. It's very acidic in your stomach. And the reason it's acidic in your stomach is you have cells in your stomach that produce hydrochloric acid. Hydrochloric acid completely ionizes. Well, I take medication for acid stomach, and it's called a proton inhibitor. I take it, and it gets into the blood, and it stops the production. It lowers the production of acid in your stomach. Why do you have acid in your stomach? Do you have any idea why you have acid in your stomach? I mean, was somebody crazy when they invented the stomach? But what kind of food? It's helped to digest food. But what's the mechanism? Does anyone know? It's an enzyme. There's an enzyme, but is the H plus ion, which makes it acidic, is that the enzyme? It is? You digest protein in the stomach. You digest protein, not starch. You digest protein. Yes? Where's your starch digested? In the mouth, you add something called amylase. You masticate it. You mix it with amylase. It goes into your stomach. It's further masticated. And then it goes into your small intestine, the first 20 centimeters of your small intestine. It mixes with amylase again and slowly digests. Yes? So your mouth and your small intestine. But the protein, your protein, is digested in the stomach. And the enzyme is called pepsin. And the hydrochloric acid is called a coenzyme. For this to work, you need to add a hydrogen ion for that to work. You need a catalyst for the catalyst. You understand? You need a catalyst for the enzyme. Yes? You get that? So when you put the acid with the pepsin, it helps to digest your food. Yes? So when my mother used to give me, it was an old wives' tale, you know, you give a spoonful of vinegar when you get a sour stomach. And you know what? It worked. And the reason it worked is what we're going to study today. Okay? And tomorrow, the next day. We're going to start it today. So we're going to look at acetic acid. Okay? Now, acetic acid or ethanoic acid, okay, or ethanoic acid, gives up that hydrogen. Right? Gives up that hydrogen. Each line without an atom is a hydrogen there, okay? It's a short way of writing it. You just put the bonds there, but I know there's a hydrogen there. When this goes into solution, okay, this proton goes over here and forms C2O2, right? H3. So C2O2 and then the H3, yes? With a -1 charge, plus the hydronium ion. So we can write the acid part of it as either a hydronium ion or an H plus, okay? When you write the hydronium ion, what is that based on? What theory am I using there? What theory does the hydronium ion come from? I'm not going to tell you. You're going to look that up. So let's get some people to look up stuff on the web. How you doing there, Nabil? Are you looking up the scores from last night? Excellent. You're actually looking up something that has to do with this class? You don't. You're not. Okay, well, that's honest. I like that. I like that. Ethiopians are extremely honest. I love that. If I could generalize in a positive way, I have 3 Ethiopian students this year, and they are extremely honest. I like that. I like it. God bless Ethiopia and Addis Ababa. Okay, now, Nabil, would you do me a favor? Okay, would you look up, where does the hydronium ion come from? What theory? Is it Arrhenius? Is it Brownsted-Lowry? Or is it Lewis? Okay? Yes? Or is there a difference? And does anybody care out there? Okay? Can you do that? Right now. So what you're doing is you have that in solution, right? Yes? But it doesn't dissociate much. Do you see how that is not going to dissociate very much? Yes? Where I have here, this is called hydrogen chloride. But when I put that, you can't see that, can you? I'll pan over here. Let me pan over. Okay, do you see that now? Okay. I'm going to pan over and kind of leave that there. Okay. So there's the hydronium ion, which is another way of writing the H ion. This is very electronegative, the chlorine, right? The chlorine is very electronegative, and that's going to dissociate completely, isn't it? Into this and this, hydrochloric acid. Yes? So that's going to dissociate completely. This is not going to dissociate so much. Why does it dissociate at all? Why does it dissociate at all? What's the story with that? Well, to teach you a little bit of organic chemistry, because you have to do some organic chemistry. In organic chemistry and biochemistry, we look at acetic acid all the time. Every problem I was doing, it seemed like when I was in college, had to do with acetic acid. But you see this? This is like my biochemistry teacher in college used to call it like an electron vacuum. Okay, it sucked up all the electrons. Okay, so the electrons were sucked up like this. Okay, making this partially negative and this partially positive. But do you see how it's a little weird to make that oxygen a little partially positive? It's a little weird, isn't it? A little weird. But there's a shift of electrons. There's a dipole literally going like this. If you could make a dipole with a right angle. Does it really have a right angle? No. But you have this kind of flow, this sucking. You know, the sucking of electrons, that double bond oxygen kind of sucks things up into it. Okay? And makes things slightly electronegative. Yeah? You get this dipole that makes a right turn. Okay? Yeah? So that's why it ionizes. But I'll tell you, it doesn't ionize much. I'm going to tell you what the Ka is. Ka represents how much something ionizes. So for instance, if I have a Ka 1.8 times 10 to the negative fifth, is that a large number? Is that a large number?
No.
Is that a large number? Diego, are you there?
Yeah.
Okay, Earth to Ecuador. Did you just go home to Quito for a minute? You did, didn't you? I saw that. He did. He went home. He was mentally there. What is that called when your mind leaves your body and it goes somewhere? It's called something. What is it? Insanity? I don't know. There's some theory or something. Whatever. Anyway, astral projection or something like that. Whatever it is. Anyway, some weird thing.
It's an astral something.
Yeah, something like whatever. Anyway, so it's not going to dissociate very much. Okay, let's say I'm going to give you a. Let's do a quick review before we do anything, okay? Let's say I give you a pH of a solution and it's 4.4. That's what the pH is, okay? I want to know what the pOH is. Let me make sure this camera is panned to the left here so you can see this. Yeah, everything's good. Okay, we're cool. So I'm going to give you a pH of 4.4. Okay? Yes? You get that? Yes? I want to know what the pOH is. I want to know what the H ion concentration is. And I want to know what the OH concentration is. Okay? All right? So I'm going to give you a pH of 4.4. I'm going to go away. All right? And I want you to come up with these values. I'll give you a little bit of a hint. Okay? But I want you to come up with those values. Clear? Are we all right on that? We're off.